In this video, I will explain what continual pre-training is and when we should consider continual pre-training. First, let's look at the typical training process for large language models. We use vast amounts of text data to pre-train and obtain a base large language model, often referred to as a general-purpose language model. If we want to solve a specific task, we might need to fine-tune the model, resulting in a fine-tuned model. This is the general workflow. Sometimes, however, we need to modify this workflow. Let me provide an example. Suppose we are working with a model like Llama 3, which is highly proficient in English, but performs poorly in German. Now, we want to use Llama 3 to solve German-specific problems, such as machine translation or conversational systems in German. Clearly, Llama 3 struggles to meet our requirements, as its German capabilities are insufficient. In such cases, we need to enhance Llama 3's German capabilities. Enhancing Llama 3's overall capabilities cannot be achieved through SFT, supervised fine-tuning. Instead, we need to fundamentally improve the model's German understanding. This is where continual pre-training comes in. Here's how the workflow changes when continual pre-training is introduced. We start with text data and a base large model, such as Llama 3, which is proficient in English. To transform it into a model that is also proficient in German, we introduce a large corpus of German-related text and perform additional pre-training. Continual pre-training is essentially an extension of pre-training. When we identify limitations in a model's capabilities, we continue training to address these gaps. The result is a new, specialized large model. Ideally, this model is proficient in German. We can then fine-tune this enhanced model for specific tasks. It's important to distinguish between continual pre-training and fine-tuning. While both involve modifying a model, they operate on different dimensions. Fine-tuning typically focuses on a specific task and aims to improve the model's performance for that task. Pre-training generally targets a broader domain, such as a language or specialized field like finance or healthcare. Now let's discuss scenarios where continual pre-training might be necessary. Domain mismatch. If the base model's domain differs significantly from the target domain, continual pre-training may be needed. For example, consider a problem in the healthcare domain. If the base model was not trained with substantial healthcare-related data, its understanding of the domain will be limited. In such cases, the model is unlikely to perform well. Continual pre-training with healthcare-related data can bridge this gap. For instance, if we want AI to assist doctors with diagnoses, the model needs to comprehend the medical domain comprehensively and make informed decisions. If a suitable healthcare-specific model is available on the market, we can fine-tune it for our use case instead of training one from scratch. Language support. Some languages might not be well supported by the base model. For example, while Llama 3 excels in English, its German performance is lacking. Continual pre-training can transform a model that does not support German into one that does, creating a new specialized model. Outdated knowledge. The knowledge embedded in the model might become outdated over time. For instance, the base model's knowledge might be current only up to December 2021. By 2024, the model would lack 3 years of updated knowledge. In such cases, continual pre-training is needed to refresh the model's knowledge. Finally, it's worth noting that in most cases, 99% of the time, continual pre-training is unnecessary. Continual pre-training requires significant data and resources. For example, to incrementally pre-train a 7B model, you might need tens of billions of tokens. Without sufficient data, continual pre-training loses its value.